Record. Good. Let's look again at the problem that we used in the warm-up. Now this was the equation that we had. Y equals 2x plus 3. Now before I show you like the theorems and all that kind of stuff, let's just use our own thinking with what we know about lines. And let's try to write an equation that's parallel to this line. So, if we have a parallel line, and let's say it goes right here, let's say it goes through 0.6 to 0.06. If it's parallel, we still are going to need a slope, and we're still going to need a y-intercept. Now, if we're looking at the slope of this line in blue, say it's parallel. If we're looking at the slope, is the slope going to change? Is it going to be the same? What do we think about the slope? Is it? Sweet. Nice job. What do we think about the slope? I know my line doesn't look perfect. This would be helpful to write down. I mean, maybe not this exactly. On the next slide, we're just kind of warming up to the idea. But I'll tell you when you write something down. The slope. What do we think? It's what?
7.
So I see where you're coming from. Who said 7? Layla did. So 7 would be our y-intercept. So I should write it up there. Right? 7 is our y-intercept. So when we're looking at a parallel line, our y-intercept will change. You're right. But what about our slope? Would our slope change?
No.
No, it wouldn't. Nice job. Our slope wouldn't change. Right? The line's parallel. That means that they never hit. So that means that they have to have the same slope in order to never hit. So the only thing that's going to change, when we're writing a parallel line, the only thing that will change is our y-intercept. That's it. Only thing that will change. Our slope will stay the same. And we'll put a theorem to that, put that in a little bit better language in a second. But we're just kind of getting used to the idea. Now, what about, this is a little bit more difficult. What about a perpendicular line? What about a perpendicular line? Let's say this is perpendicular, that it comes in perfectly at 90 degrees. And if we're writing an equation for it, is our slope going to change? Is that a yawn? What do we think? Is our slope going to change?
Slope.
If we're writing a perpendicular line.
Yeah,
it's going to change. First thing, our original line is going in the positive direction. Our perpendicular line is going in the negative direction. So we know that it has to change from positive to negative or negative to positive, whatever way around. Now, what we say with the number, like if we have a slope of 2, then if we're writing a perpendicular line, the new slope, it changes sign, like I said, from positive to negative, but also the value of the slope becomes the inverse. So instead of 2, the slope would be 1/2. So when we're talking about perpendicular lines, we would call the opposite inverse. It's opposite because we change from positive to negative. It's the inverse because instead of 2, we have 1/2. And now the y-intercept also would be different, right? It's right around here. And let's just say it's about 7. So the y-intercept would also change. Do we see how that makes sense? How a parallel line would have the same slope? Why that makes sense? Because that means that they would never touch. And the perpendicular line is a little bit more difficult. It would have an opposite inverse slope. So if we were going to put that into theorems, you knew they were coming, Sawyer, but we had to put them into this is what you would want to make sure that you write down. Theorem 3.13. It says in a coordinate plane, so on a graph, two distinct non-vertical lines, so two lines, are parallel if and only if they have the same slope. So the only way that we can know the two lines are parallel is if they have the same slope. That's all that that's getting at. That's the only way. You see that all the way back here? You what? Barely. I guess I could make the words a little bit bigger too the next time. Do I need to make them that much? I see there. Well, it would be more actually like joking aside. Hopefully set close to the door so you can see better. Now with perpendicular lines.
Go back.
You were done?
Oh, we weren't
Oh,
done.
sorry. You don't have to write down every word of that. The idea is that we can only know that two lines are parallel if they have the same slope. That's it. That's the main point there. You good?
Yeah.
3.14. In a coordinate plane, so on a graph. Two non-vertical lines, so two lines, are perpendicular, so they intersect at 90 degrees, if and only if the product of their slope is -1. So, like in our example, I guess I can just write it right on here. In our example, we had these two equations in the last example. I'll let you guys finish writing, then we'll go over that again. The main point is that two lines are perpendicular if and only if the product of their slopes is -1. All that means, in our example, we had our original line was like y equals 2x plus 3, and then the perpendicular line that we wrote is right here. Y equals -1/2 x plus 7. So all that's saying is that if we take our slope, 2 times -1/2, that we know that these two lines are perpendicular if this equals -1. Well, 2 times 1 is 2 over 2. So the lines that we wrote are perpendicular because when we multiplied their slopes together, we got -1. That's all it's saying. Zoom out. We good to move on? Okay. So, a couple examples. Write equation of a line. This is exactly, the type of language that the homework and that the test and everything will use. write an equation of the line passing through point 1, 1, negative 1, 1. So that's to pass through this point, and it's parallel to the line right here. Y equals 2x minus 3. So if we kind of over here are starting to write our equation, let's say on this left side we're doing our work, what do we already know? Is that
Yes, it is.
okay, nice. What do we already know that the slope of our line has to be if it's parallel? The same. Yep, if it's parallel, it has to have the same slope. So if over here we're kind of writing our equation, we already know that it has to be y equals 2x. Now we just need to find the y-intercept, right? So we talked about two different ways that we can find the y-intercept, right, Taylor? We talked about two ways. The first one we talked about that, hey, we can just count on our graph. So the slope of 2, 1 is a rise of 2, run of 1, so we can count 1, 2 over 1. We could find that our y-intercept is positive 3. Or we could use the point that they gave us up here. Using what? So we can see the circle. We could use the point that they gave us, and we could say we know for sure that y equals 2x plus, and we're looking for that y-intercept, that b value. Well, our new line goes through point negative 1, 1. So y equals 1 plus b, and we could solve for our y-intercept. We would find it either way, that our y-intercept is 3. So whatever way you feel more comfortable with. Counting on the graph or plugging it in. Good with whatever. So that would be writing a parallel line. Write equation of the line passing through point 2, 3. That is this time perpendicular to the line 2x plus y equals 2. Now, the first thing, the form that they gave us that line in, 2x plus y equals 2, we don't like that form. Because we don't know what our slope is, what our y-intercept is, it's kind of difficult to see. So, if we rewrite this to solve for y, you're good, I see it. If we rewrite this to solve for y, then we can subtract 2x from each side to get y by itself. Y equals negative 2x plus 2. You see that? We're just solving to get y all by itself, so it's in a form that we like, a form that we can use. Now, our new line, we'll start it over here. What does the slope of our new line have to be? It has to be an opposite. So remember, if our original is negative, our new one has to be positive. An opposite inverse. So instead of 2, it is just 1/2. Good question. Is that what you're going to say? You're not raising your hand. Oh, sorry. Yeah, super excited. So an opposite. So we went from negative to positive. Inverse. Instead of positive, just the whole 2. Our inverse would be 1/2. Do we know what the inverse of just the whole number 4 would be? 1/4. What about the inverse of 2/3? 3/2. Yep, it's just flipping that fraction. So we know the idea of an inverse. You good? All right. Now, again, when we are looking for our y-intercept, we have a couple options. We can draw a graph, and we can say we know it has to go through point 2, 3. We know it has to go through here. Well, our slope is a rise of 1, a run of 2. So if we go down 1, 2, you should get a y-intercept to be right there at positive 2. We can just use our graph and we can count these rise over run. Or again, we can solve for it. So y equals 1/2 x plus b. We're solving for our y-intercept. And we're using the point that they gave us. So 3 equals 1/2 times 2 plus b. 3 equals 1 plus b. And we'll still get the same answer. And our b values and our y-intercept is positive 2. Questions on that one? Last one. Find the distance from point 1, 0. This is another type of question we'll see. From point 1, 0. So that would be right here. From this point to the line negative x plus 3. So if it's negative x plus 3, positive 1, 2, 3, we know that it is going through this point in the negative direction. So it would look something like this. If we're just sketching it to give us an idea, we want to find the distance from here to our new line. So it's similar to what they did yesterday, except they don't give us like 3 lines to choose from or anything like that. Just want to double check. This one. This should be the right direction. So in this case, if they want us to find the distance, the easiest way to do that is just to write what the equation is for our perpendicular line. Because the line that's going to go through here at the best angle and the quickest is going to be one that's perpendicular. So if we're writing the equation for a perpendicular line, y equals, we have to have the opposite inverse slope. Well, this is a slope of 1, so our slope would just be positive 1 this time. We're just switching from negative to positive. X. Now intercept. Solve for, so 0 equals 1 plus b. Intercept then would be negative 1. So here's the equation of our line that's perpendicular to our original. I don't think there's one like that on the test, so I'm not going to go any further with that. Just writing that equation of a line that's perpendicular is where we will stop there. We won't worry about the distance right now. So the main things that we looked at, well, really 2 things. Write an equation of a line that is parallel, and then write an equation of a line that is perpendicular. Those 2 things are what we need to know today. But since I know for some people, writing equations like we did in the warm-up, for some people, super easy. We can do that, no big deal. But for others, we haven't had as much practice with it, so it's a little bit more difficult. If we're, like I said in the very beginning, if we're comfortable with what we did in the warm-up, then what we learned today isn't going to be a huge deal. But if the warm-up was a little bit of a struggle, then today we might need to catch up a little bit. Questions on those things? Hopefully in your notes you have an example, or at least one example,
of how we wrote those parallel lines and how we wrote those perpendicular